and let's do this again. Okay, start Blender. Oh, and I will tell you one more thing. If you start Blender using like the start menu or whatever, that's fine. But when OSL doesn't compile right, the error messages go to the console. It's really annoying because if you launch it without a console, there's no console to see the results, and so you don't know why your stuff doesn't compile. So if you can start Blender from the command line, then you can see what's going wrong. So Laura will figure out how you can start this using PowerShell. I'm just going to start it here from my terminal. Okay. So now here's Blender. X for delete. Shift A brings up like your creation menu. This is kind of like Tab in Houdini. We can make a monkey. If you select it, so Blender is a slightly different system than Maya. It has a thing called a modifier stack, which is kind of like chaining things together in Houdini. So if I want my monkey to be smooth, I have to give a subdivision modifier to it. The modifier stack lives under the wrench. I can add a modifier like subdivision surface, and then it will render as a sub D surface. By default, it doesn't smooth the normals, and so if you want smooth normals, we say shade smooth or shade auto smooth. It's on the right click menu. Okay, middle mouse button gives us the orbit, middle shift pans, and middle control zooms. It will be painful, but you will figure it out. Hopefully you won't have to do that much. This is only a week assignment, or a week-long assignment. It should be a strong assignment. I'm going to add a grid. I'm going to scale it by using the S key, but I could also use the move, rotate, and scale handles here, or like the universal one. Okay, so I'm just going to go back to selection mode. I'm just going to hit S for scale. I'm going to hit G for grab, and I'm going to move it in the Z direction. And then I'm going to click here for the shading. This is the default shading, which is hardware. I'm going to switch it to cycles, which is ray traced. And now we get all of our global illumination and everything like that. If you don't want to see like the grid or anything, you can click this button and it'll turn off all the extra OpenGL stuff that's being drawn in the viewport. Up here is the outliner-like thing. It doesn't really behave exactly like the outliner. I still haven't taken the time to figure out how it works. It's kind of weird. But you can grab your light and you can move it. You can duplicate stuff by hitting Shift D, and then you can move that too. Okay? If you want to shade stuff, we can just go to the shading tab up here, and it's going to switch back to the hardware shading mode. We're going to click back to cycles. Okay, when we select an object, down here, this is the material. It's also automatically selected here. It says that Suzanne, which is the name of this model, is the active one. I can hit new shader here, and now I have a shader. I can adjust the patterns. I can hit Shift A and add noise, texture. I can connect it up. It's just like Houdini stuff. It's just nicely interactive, which I like. Okay? So, now let's get into how do we do OSL. So the nice thing about Blender is it has a mode for about anything, and one of the things it has is a text editor. And this is convenient because we can actually type our OSL code here and reload it here. So to make an OSL shader, we just hit Shift A and type script. If you do this in RenderMan, you can just create the OSL node. And in RenderMan, you will load a file. Here, Blender likes to keep all of its data inside of the blend file. So with the text editor open here, I can say new, and I'm just going to call this simple noise.osl. So now I have an OSL shader text file loaded in Blender, and if I click here, I can load it up. If you click this external thing, you can use an external text file and you can edit it using an external text editor. That's fine and dandy. This is convenient. So like I was saying, we have shader. We're going to call it simple noise. And it's going to have some parameters. So I'm going to make an open brace, and then I'm going to give a frequency, so float. And I'm going to give it a default of 1. And I'm going to hit a comma. If you put semicolons here, it will error out. Your last one shouldn't have a comma. So we'll do a comma, and now we're going to do an output color. So output, color, and the result.
Is this its own shading language, or is there like something underneath?
So explain your question.
Like kind of like how Unreal is just glorified C++, you know, is this...
This is its own shading language. It gets compiled. There's an OSL compiler that you can run on the command line.
Okay.
Everything is ultimately glorified C++, right? But yeah, this like the whole point of the OSL compiler is that it can optimize your network. So if you wire a whole bunch of nodes together, you can the OSL runtime will try to optimize the way that those pieces run. But yeah, this is a C-like language, very C-like, which is nice because then you don't have to worry about indentations or other like non-C++ style like behaviors. I have a document where I've taken like the most relevant parts of the OSL coding document and like pasted it in there so you don't have to dig through their documentation, but there's full documentation online. OSL belongs to the Academy Open Source Software Foundation. So here's our simple shader. Let's do something very simple. We're just going to say result equals, we're going to do 1, 0, 0, which is red, right? And all we have to do is load this in here, and it says there's an error. So then we look on the terminal and say, what's the error? It says compilation error. Shader parameter result requires a default initializer. Okay, so I didn't have a default here. The default is going to be 0. I'm just going to reload this, and now you'll see that it's automatically populated this with parameters. And if I take this result and I plug it into my shader, then it's funny because that doesn't look red. Let's look at the code. Result equals, maybe I have to say, result equals color 1 output. Live demos. Okay, hold on. Okay, and now the reason why this isn't working is because you have to go into these render settings and tell it that you want to use open shading language. And there, now everything's going to work. So if we go back to that and reload, now it's going to be red. Yeah. Yes. Okay. And it looks okay, good. I've had problems where sometimes I pause and start OBS, or if I try to do 2 recordings, it fails to start the second time. Not cool. Okay, so here we have a simple shader. I don't think this is necessary. It'll probably work fine without it. No, it does want that. Okay. Now, let's say we want the user to be able to provide a color as an input. Okay? Now we have, and let's have that output into result. We're just going to reload that, and now we have an input color. Whatever we select here is going to go to the output, or I could even plug another noise texture in here, and that works. So you can plug things into these inputs, you can specify them, everything's good. So now let's do something a little more interesting. So I called this simple noise, so let's do noise. If we look at the documentation, not that documentation. And so this is, I will share this with you, or you could also look on the OSL website. There are a number of different noise functions. You can specify the kind of noise. If you look at the documentation, it'll say what kinds there are. But we can also just do noise, which will give us the default, which is Perlin. So, and the noise parameter will take basically what parameterization this is using. So it could use the UVs, it could use the position. So we're just going to use the position. So I'm going to say noise, and I'm just going to use P. There's a bunch of built-in variables. Let's see. Built-in. Okay, so there are built-ins. If you see here in this documentation where it says these functions are built in, it also says where they're available. So you have a surface context. This is like shaders, materials, patterns, and these variables are available. If you're doing a displacement shader, these variables are available. So it says P is read-write, whereas with a surface, P is just a read variable. Normal is read-write, read-write. NG is the geometric normal versus the smooth normal. This is the derivative in U and the derivative in V, and those are both read. And the UVs are specified here, they're read, and that looks like the way things work. So CI is an input color that is on the surface, and it is read-write for a surface as well. So there's also constants like pi, pi divided by 2, pi divided by 4, pi 2 divided by pi, so on and so forth. And then there's the basic math functions, right? So let's go in here and do a noise. We're just going to do noise of P. And because I did this before, I know that P is quite, like the frequency for P is quite high. So if we run this, you'll see, oh, wait. Not this time, I guess. Okay, so see our noise? If we want to change the frequency of it, we can multiply by the P by frequency. And we'll just reload that. And now I have a user control where I can say what frequency do I want this noise to be computed at. Okay, questions so far? See, I have frequency as a variable that's declared as an argument to the shader, and so it's exposed right here, and then I can just use noise. This P is a built-in variable, and frequency is this one here, and then I can control this using this knob, or again, it's mappable. So if I wanted to, I could control it using another pattern. Right, because P is the actual position of the surface, right? So if I move this, you'll see that the noise changes because the object is moving, but P is defined relative probably to world space. If I wanted to do something like, okay, now I'm diving into realms that I haven't tested so far. Let's say we want to use P in local space. So I'm going to do point PL equals transform And we'll try this. Object, sorry. We will see if this works. We might need to check the documentation. This is where my RSL knowledge collides with OSL, and they're not exactly the same. Okay. Now, it's still not working. Oh, wait. PL. Here we go. It didn't not compile, which is a good thing. Now let's use PL. Reload that. And now it sticks. Because now I'm taking the P and I'm transforming it into object space. This is just the same as using a coordinate system. It's just that every object has a object space as their first coordinate system. You can use other coordinate systems in Blender. We're not going to worry about that right now. If you look in the documentation and we look at transform, there's F-O-R-M. Okay, there's different transforms. You can transform. So this is a shortcut of not specifying the from and the to. This is just providing the to space. You can transform from a space to a space. Common, I think, is OSL's version of camera space. So if we turn this into common, we'll just do it should be locked to the screen. So if we rotate around, you'll see that it stays similar. Yeah, okay. You can also do things like, there's different spaces, and I'm not going to delve into this too deeply, but if we were to do stuff like equals this will transform it into the normalized device coordinate of the camera, which means that it will go from 0 to 1 in relation to the screen. And so up here, it's the top, down here's the bottom. And so if you wanted to map a texture relative to that, then you could use NDC space. So like if you wanted to project a texture onto the surface from the screen, you'd use NDC. There's other spaces. Look at the documentation. Or if you want to do your noise in NDC space, now I'm using my color variable multiple times. It's okay. Or maybe it's not. Let's see. Result times frequency. Maybe it doesn't like that. Okay, it says, oh, come on, you guys should have caught that.
So caught what?
I totally didn't type the variable right.
Wait, frequent.
Okay, so now my noise is defined relative to the screen.
I've got a question.
Yeah.
What is noise returning?
Noise returns whatever data type you're asking for.
Okay, so because we declared result as a color, it's sending color.
Yeah.
Okay.
If we ask for a float, it will give us a float. Oh, no, it doesn't like that syntax. Oh, did I? Or no, I left out a parentheses. So, here's our noise in screen space. You can also process these things, like we've done some stuff with like a threshold. Threshold can be done with a step function.
For the float, it was color, right?
Yeah, right now it's a float. So Step, you'll say where you want to do the transition. This is just like your if, and then here's the input. And if we run that, then we should get a black and white result.
Ooh.
And again, we can change our frequency. There's also another function which is very handy called smooth step, which gives a Hermite interpolation between two values to give you a soft transition. So if we want to do like from 0.5 or 0.1 to 0.5, that will be our transition. Hermite interpolation gives us a nice smooth, it'll start out smooth, it'll come in, and then it's kind of an S-shaped curve. So if we do a Hermite interpolation there, we will see now we get a smooth transition between the two. And this is where writing shaders is cool, because you can say soft, let's say float cutoff equals 0.5, float softness equals 0.1, and then we'll go in here and we'll say we want the cutoff, the start of the transition to be cutoff minus softness, and we're going to do cutoff plus softness. And if everything is typed right, then we will now have a cutoff value, and we can control the threshold between this. Okay, so there's lots of history in making patterns. It's like you can implement all the things that we normally use using OSL. Let's look back at the slides. Okay, so that is a simple pattern, and let's do another one. Let's make a HSL adjustment node. How are we doing on time? Okay, this is we'll do this one. It's going to make another script node, and we're going to make a new text file, and this is going to be called HSL adjust. Gonna load it using this HSL adjust. Oop. HSL adjust. And reload that. Okay. Shader. And again, we're gonna have our output. And it's initialized, and we're gonna have our input. And it's gonna just default to 1, and we're gonna set the result. It's good to do this incrementally, because you don't want to be dealing with it's like modern Python and C++ compilers give you really nice detailed error messages, and it's so easy to debug. This one's the worst. It'll tell you there's something wrong on a line, and you have to fix the syntax error. That's the way it used to be. We live in a golden age now. So we start off with baby steps. The result is equal to the input. And so you have to normally connect these up, but Blender has lots of add-ons. And add-ons allow Blender to do stuff better than it would do by default. And there is one called Node Wrangler. If you turn it on, then you can do nice things like hitting the O key to connect your node to the output automatically without having to wire everything up. It's super nice. Okay, so now here's our HSL node. Let's load a texture. Image texture. Just gonna open one. Okay. Here's a sample texture. It has colors. Okay? So now let's start implementing our HSL node. So it's pretty easy. We're going to have a color and temp color, or we could call this the HSL color. It's always good to write your code so that it tells you what it's doing. HSL color, we're going to take our input color and we're going to transform it into another color space. So we're going to do transform C. I think. Well, I'm going to show you that we want to look here. Okay, transform C gives us our color space. It's just like transform. We're going to say transform C color space. So we're going to go from space and to space. And yeah, so here's the documentation. So our space is going to be from RGB, and it's going to be to HSL. And we're going to use the input color. And we're going to set this result we will just take this result and put it here. If we reload this, we have error messages. Just put color. And it says oh, probably. Okay, almost. I seem to have broken my connection to my texture. Okay, there. Here's my texture. Now this is what it looks like when you use the HS and L values as RGBs. So that's wrong. So now we need to get it back. So we're just going to say and this time we're going to go from HSL to RGB. Okay, so now it's back. So now we can adjust the HSL. So we're just going to do HSL color dot R plus equals H offset. And we're going to make an H offset. Okay, reload that. I know this is boring. Hang in there. So now nothing's going to happen, but as we turn this H offset, things are going to change. Now this is 2 disco. Hue is usually dealt with in degrees, and so we're just going to divide this by 365. And now we can use values between 0 and 365 to do our offset. And now let's add the saturation. 360. Thanks.
365 days.
360. Yeah. Well, you know, it worked. I could have divided it by anything. But yes, thank you. I'm going to use the S offset to.
What's the H offset? That's the hue, right?
Hue offset. Yeah, I could have typed hue.
And then say saturation offset.
Yeah.
And this is offset.
Since I don't have autocomplete, it's nicer to type things that aren't too long. And compilation failed. It just. Thank you. G. Okay, so now I have a saturation offset. And finally, luminance offset, because I did HSL. The funny thing is, it's like transforms into like HSL and HSV are actually a lot more code than you would think they should be. I was isolated this from years because in RenderMan I could just transform into whatever color space I wanted to. The reality is to get to HSV you have to first transform into HSL. And so I think that's why you see HSL transforms in Substance Painter and not HSV.
Why are you the dot R dot G? That's like the red green channels, right?
Yeah, because this is a color.
Oh. Okay.
I could also use X, Y, and Z syntactically, I think. We'll find out.
So you're changing like the hue of just like the R channel.
Uh-huh.
Okay.
So since when I transform it in HSL, the first channel becomes the hue, the second channel becomes the saturation, and the third channel becomes the luminance. And so by editing those values and then transforming it back into RGB, then I get the result that I want where I'm adjusting the hue, saturation, and offset. Okay, let's see. Thank you. Thank you. Okay, and it doesn't like that, maybe because it's a color. So R, G, B. Okay. 0 for my hue, and now here's my luminance. And you see it's going like super white. We can always like clamp this. This just makes sure that our values don't ever exceed 1. So now if my offset is greater than 1, it doesn't get super bright. It also doesn't go negative. And then once we've done that, then we just transform it from HSL back to RGB and return the result, and now we have a handy HSL node. Yes?
I can also set the parameters to be like from 0 to 1.
Yes. I didn't include that piece of the documentation in my doc. There are ways to say that you want, I think it's like, let's try this and see if it respects it. Let's do it on this one. So it's got this double square brace thing, and then I think it's string, range. Nope, that's not going to work. I will have to look and see.
Does Godot use OSL?
No. Godot uses HLSL, which is, or GLSL. I don't remember which one. GLSL is OpenGL shading language. It's like there's this whole, heritage of SLs. Okay? Does that make any sense to you whatsoever?
Yes.
Because I'm going to have you do patterns, it's like you can also do like full materials. And in my slides, I do have that documented. Like if we wanted to do a material like a glossy or a diffuse material, instead of returning result, we're going to use a thing called a closure. So in RenderMan shader language and in older shader languages, all the math for doing the lighting was computed in the shader. And this is how like hardware shaders work as well, where you will get the lights in the shader, you will iterate over the lights, and you'll return the result. For performance reasons, OSL uses a thing called a closure where you parameterize the closure, but you don't actually do the lighting computation. And so like the simplest one would be just to use diffuse, so I'm just going to copy this. So if I wanted to make a new shader, just going to do a new script, Get a new text document, paste this in here, and call this diffuse shader. Okay, load that, and it says it doesn't like something.
You don't have to see the code.
Thanks. The hazards of copying code from a slide. Okay, compilation successful. We'll hook that up, and now, look, it's a diffuse shader. And if we want to add specular, we can do that too. The way that closures work is that you give the parameterization, like I provide the normal and I multiply it by the result. It'll compute this part and kind of store the result of what is multiplied by diffuse in this closure color, and then the results will happen when the renderer wants them to. So if I wanted to add a specular, I can add this one. It gets a little bit more hairy. And okay, I'm gonna add. So I need to parameterize the amount of reflection, the amount of refraction. So this is transmission, KT. This is the reflection, which is KR. So K is for coefficient or constant, however you want to say it. It's just there's history there. KD was used typically for the diffuse constant or coefficient or whatever. So KD, KT, KR, KS, that's how shaders have been written for time immemorial, so that's what we do.
What formula is this? Like a phone? What is it?
So this is a function. This is a built-in function. The closures are defined by the renderer and by OSL. So OSL has some closures. Blender doesn't necessarily support all the OSL closures that are defined in the documentation, and there's closures that are defined in the Blender documentation that are different than the OSL documentation. It wants a normal. It wants, I forget what the second argument was. It wants the reflection and transmission. It wants a roughness value. And I feel like I've got duplicated code in here. For convenience, we often square the roughness. Because it makes it behave more linearly. So that otherwise you have to use like 0.01 for a sharp thing. If you square it, then you can use like a 0.1 for sharp things and 0.5 for medium. It's just a convenience thing. And
I think you said square.
I need to provide a roughness. Okay, so got roughness and got KT, KR. This is the index of refraction, and this is the microfacet model. Let's cross our fingers. And, of course,
I think you need to capitalize the K.
oh, I
and
spelled
the mess square.
this differently. I saved myself. And these need to be capital.
Scruff.
Okay, cross your fingers. Hey, and then we have shininess. And we can change the roughness. And I can change the colors. And I can plug in our HSL node. And let's see. Do we want to do one more? I think we can get this to work in the remaining time. Okay. I did look into the keyword for this, but it doesn't provide the right user interface. Okay, and okay, so far so good. And now if we provide a file name, which I think we can reference it from within Blender, but we're just going to copy this name. And now we can do cross our fingers. Compilation was successful.
Do you need the full file path and not just the name?
Yeah, let's see. Did Blender put in the full file name or just, oh, yeah. All right. What did I call that thing? Sample texture. Okay. Okay, we got the full path.
Huh?
Oh. It looks like, so we've got the U and V texture of the individual faces. I don't know, we may need to plug in the texture coordinates. So we will do that. Uh, 0, 0, 0. And the thing you don't usually know is that the y coordinates are flipped. So like there's this great lie that happens to us. It's like we work with all of our textures in an upright position, but to the render 0, 0 is at the top upper left corner, and so if you don't invert your UVs, then it won't do the right thing. And then this is not in the right color space, so we'd need to transform that from linear to sRGB. You can, it's not right, but the square root is close, if I remember correctly. Let's see if I'm right. No, squared. Or, I don't know, I'd have to look at that. Square root wasn't right. Seems like squaring it is wrong. All right, how close does that look to our default one? Anyway, And that's OSL shaders.